Now take the solution about that. है ना, slider mechanism. Okay, so a slider mechanism we can use for the, now if I am talking about the external undercut, so external undercut has also few types. See here, side wall undercut. See, side wall undercut. See, this is the hole, this is the feature. So side wall undercut. Circular undercut. This is nothing but this is the bobbin type of undercut. है ना, this is the bobbin type of component. So you can see that this is the complete undercut by for which we can use the slider as well as we can use the split mechanism also, right? Now you can see the full undercut. So for the full undercut again we have to use the split mechanism again. Okay, and sometime for example we have to use the multi slider also. Now for example we have a component like this. We have a component like this, and we have a component like this, and this is the undercut here, this is the another undercut, this is the another, this is the another undercut. See, there are lots of undercut at any face, and this undercut is nothing but it is the perpendicular with the face. Now for this we have to use the multi slider mechanism, right or wrong? This is the one slider, this is the another slider, this is the another slider, and all the single slider or the individual slider will be perpendicular with the face, with the related face, right or wrong? Okay, understood? Okay, now see external undercut. So for this type of undercut, like side wall undercut, we have to use the slider mechanism or the pin system, and this pin further again it will be connected with the slider or the side core. Okay, then that side core will be actuated by the spring or the cam pin, है ना, and same mechanism for this, right? See, है ना, again for the split as I told you, this is the solution. Okay, this is the split 1, split 2. Okay, this is the full undercut. So for that we have to use the multi slider mechanism. So for example we have a two faces. So for the two faces we have to use the two slider. For example we have a four faces, so we have to use the four slider. Right or wrong? Understood? Now see the slider mechanism, how it will work. See, what is this? See here and observe the carefully what is happening here. Tell me. Tell me. See, what is the purpose of this spring here? Tell me. And what is the purpose of this wedge? This wedge. Tell me. This wedge has, for example, this wedge has a radius like this. Na? Anyone? Vijay? Please tell me what is happening here.
It is synchronized, the ejector pins and the upper wedge.
Okay. Okay, so this is the slider. This wedge and this wedge will be met to each other, and this portion, this wedge or the heel block, you can say that it will push the slider in this direction, right? It will push the slider into this direction. Okay, and this spring will be compressed.
Yes.
Okay, once mold will be open, so then again this spring will try to regain its original shape. Okay, so that's why it will pull the slider again. So that's why this undercut will be released.
Yes, yes.
Okay, now see here, this is nothing but this is the cavity portion, this is the core portion, this is the slider or the side core portion. Now this is the spring. This is the spring. So this is nothing but this is the simple type of mechanism, and a slider mechanism you can say that. Okay. So here you can see that this is nothing but this is the wedge. I am directly using the wedge. For example, for the small slider or small undercut, we can use directly this wedge. But for example, if we have a big undercut like this, for example, we have a 1 minute again. For example, we have a undercut like this. We have a car type component like this, and we have an undercut like this. Okay, so for this type of undercut, we have to use big slider, right or wrong? Big slider. Okay, which weight has around 20 to 30 kg just for the toy car, you know, just for the toy car. And 20 to 30 kg, just for example, like 40 kg or the 50 kg. So for this type of slider, we have to use angular pin also. What we have to use? Angular pin. Why? Why we have to use the angular pin? Tell me. That for the movement of the slider, right or wrong? For the movement of the slider, right? This type of spring actuation system we can use only for the small slider, not for the big slider like 50 to 60 or the 80 kg, right? Depending upon the force, we have to use the spring. So we have to select the spring depending upon the weight or the mass of this block, right or wrong? Okay, otherwise for example, if we are manufacturing the big component like automobile component, then for the movement of the slider we have to use the hydraulic cylinder also there, right? Why we are using hydraulic cylinder there? Why we are not using spring there?
Because the capacity is more.
Yes, that's why, because of that capacity, right? Okay, we required the more capacity, that's why we are using hydraulic cylinder there. Okay, so this type of spring actuation system we can use for the small mold like 300 or the 400 or the 500 by 500 by mold, which has a length about 500 or 500. So there we can use the spring. But for example, if we have a big slider or the big movement or the heavy slider, you can say the heavy side core, then we have to go for the hydraulic or the pneumatic cylinder, right? Understood? Okay, so first of all we have to learn this. See here, so this is the component we have here. You can see that this is nothing but this is the heel block portion. Okay, now see, now see here, 1 minute.
Sir?
Yes.
For that, again, for the ejection of the part, you have to use lever.
Yeah, sleeve is nothing but it is the type of ejection system, like pin ejection. For example, pin. What is the working of pin ejection? Pin is directly forcing the component, right? But if I am talking about the sleeve, so sleeve is nothing but it is for the edge of the component, right? By the sleeve, component edge will be contacted, right? So you are asking about the sleeve or something else?
Yeah, sleeve.
Yeah, sleeve is nothing but it is used for the ejection system. Don't worry, I will show you a mold in which I have used the sleeve ejection system. Don't worry, okay? Understood? This is nothing but slider mechanism. Slider mechanism. Now see here. Now, what is the angular pin? What is the angular pin? Now, angular pin is responsible for the movement of the slider block in order to remove the external undercut. Now, for example, if we have a big or the heavy slider or the side core, then we have to use the angular pin. With the spring actuation system, we have to use the angular pin also. Now see here, we have a big component here, and this is nothing but what is this? This is the undercut here. This is the undercut. Now you can see that, you can see here. Now see, this is the angular pin which is attached with the cavity plate. Okay, understood or not? Now what is the purpose of these? See here. See what is happening here?
It is aligning it.
Yes, it is aligning. Basically, this point and this hole of this slider will be aligned to each other, right? So now you can see that basically this heel block also will be there. Heel block also will be here, right? But now this heel block, it will become the locking block. It will become the locking block, right or wrong? Okay, now see here, see? Okay, now here you can see that this is nothing but, what is this? This is the stroke. This is the stroke. And what is this? This is the edge. This is the edge, which is the height of the slider or the height of the side core. Now, depending upon this two distance, है ना, two parameter, you can say that depending upon this two parameter we have to calculate the angle. We have to calculate the angle. Now see here. See here you can see that stroke is nothing but it is the undercut plus few clearance. Now for example, understood or not? So basically for example, undercut is nothing but it is the 5 mm. Just for an example, undercut is the 5 mm. So you will open the slider or you will slide the slider only 5 mm or more than this 5 mm, right or wrong? You have to take few clearance also, right? Like 2 mm or the 3 mm, right or wrong? For the safety purpose, you have to slide more. So that's why with the undercut, we have to add the clearance also. So that's why it will become the stroke. It will become the stroke. Now H is nothing but height of the slider or the side core. Height of the slider or the side core. Now tell me how to decide the slider height or the side core. Tell me how to decide the height of the slider.
Height of the component.
Depending upon the height of the component. Now for example, if we have a component like this. Now for example, if we have a component like this and this is the feature into the component. Now this feature. Now I can take the slider height this, right or wrong, or I can take the slider height this, right or wrong, but we cannot take the slider between these two features or here or here. Why? Because if I am taking the slider height here, here and here, so basically this will create the extra parting line, right or wrong? So we don't want to create the extra parting line on the component because of the appearance purpose, right or wrong? Acha, understood or not?
Yes, sir.
Okay. So basically we have to decide the height. What height I can take? I can take the height either 20, either 30, either 40. But depending upon that, we have to select the angle first of all. Okay. Now see here. For example, just generally we can take the angle. We can take the angle 16 degree to 20 degree, 22 degree. Okay. I can replace this 22 degree with the 25 degree also, but I stop the angle and I just telling you that 22 degree is enough, right? Because we are taking the angular pin here, है ना? So apart from the angular pin, we have to use the heel block or the locking block also. Now for example, if your angular pin angle is 22 degree, just for an example, 22 degree if you are taking, so for the angular block you have to take the more than 2 degree. Then for the for the heel block you have to take the 24 degree. Is it clear? Why? What is the reason of this? The angle of the heel block always will be always greater than cam angle. Okay. For example, if this angle has 18 degree, so this wedge or the heel block angle will be 20 degree. Understood or not? But why? Because this is nothing but this is a locking block. Achha, what is the purpose of this? Why we are taking 2 degree more angle for the heel block? Tell me. Achha. From where force will be applied on the mold? Tell me. From which side? For example, from this side force will be applied by the molding machine. Right or wrong? Right or wrong? Now, just for an example, this is the pin I have. This is the pin. Okay? And this angle has 18 degree. How much? 18 degree. Now just apply the force. For example, you are applying the force, like for example 1 unit, 2 unit, 3 unit and the 4 unit. And now depending upon the angle. Now increase the inclination angle. what is happening here? I am increasing the inclination angle. Okay, so for example, by the 18 degree, it will affect the 4 unit. Okay, but I am taking the angle 20 degree here. Here, so basically it will affect the 5 unit. So basically you can say that for this heel block there will be more force which will be applied by the machine, right or wrong? Because of the inclination, right or wrong? Acha, you understood or not? Vijay, tell me.
Yes, understood.
Understood? So generally,
Yeah.
if I am talking about the angle of the angular pin, then this is the range 16 to 22 degree we can take. है ना? 16 to 22 degree we can take. Here, see again, for example, this is nothing but this is a stroke. From this point to this point, this will become stroke. Okay, for example, this angle is nothing but this is the 18 degree. So with the same 18 degree angle, can I increase the stroke? Tell me. Tell me. For example, this stroke is 10 mm. Okay, and with this same degree, we need 15 mm stroke.
Yes, we can do this.
How?
We can reduce this angle 18 degree.
We can increase this.
Yes, we can increase this.
Increase this length. So by increasing this length, we can get the more stroke. Understood? So that's why I told you about that. This is the important point. Okay, by the increasing length of angular pin with the same angle, we can increase the stroke length. Okay, so stroke length is not depend upon the angle. Understood? So, but there is a limit. That's why inclination angle should be between 16 to 25 degree. But it should not be greater than 25 degree. Why? Because if you incline more, so there is a possibility that your angular pin will be break because the higher inclination. And because of the higher inclination, there will be more effect of the force on the pin. That's why it can be break. Understood? Now, just for an example, for the calculation, see here. Now, stroke is nothing but undercut plus clearance, and minimum clearance I can take 2 to 3 mm. Okay, and height is nothing but height will be the constant value which is depending upon the height of the component. Right now, I am taking the height of the component, right? Now, suppose, for example, undercut is 5 mm, H is nothing but 35 mm. Now, calculate the angle. See here. So, angle is nothing but it is the 12.87. So, how much angle you should take? Tell me. So, it is nothing but it is the verification. It is the verification that if your angle is less than or the equal or less than 25 degree, so you can take the range between 16 to 25 degree. Is it clear? But if you calculate the angle more than 25 degree, then and there is no possibility for increasing the length of the angular pin, then we have to use hydraulic cylinder or the pneumatic cylinder, right? Just for an example, you have a mold like this. See here, this is the cavity and this is the core. Now here, for example, you are using the angular pin, but there is a limit for increasing the length of this, right?
Yes.
You cannot take the length of the angular pin like this. That right or wrong? So there is a limit for that. So for example, if your calculation है ना, by the calculation you getting the angle more than 25 degree, or there is a limit, or you cannot extend the length of the angular pin. So where you have to use hydraulic or the pneumatic cylinder. Is it clear?
Yes.
है ना, is it clear? Okay, तो if the angle is 12.875, है ना, by the calculation you get this value, so you can take the 14 degree, 16 degree, or the 18 degree, or the 20 degree angle. Is it clear? है ना, what was the missing in this lecture? How to decide angular pin diameter. Okay, how to decide angular pin diameter, है ना, this
Okay.
was missing. And how to decide the spring length and guide rod diameter. What is the guide rod? This is the spring and this is the guide rod, right?
Okay.
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 How to decide, and why we take h, height of the part, for the calculation. So you got the answer for this, right? You got the answer of this third question? Why we take h, or the height of the part, for the calculation? Depending upon the appearance. Okay, for example, if you have a component like this and customer says there is no requirement for the appearance for this face, okay, there is no, okay, this is not the critical feature, so you can take any height for the slider, right? You can take any height for the slider, but because of the appearance purpose you have to select the appropriate height depending upon the component geometry. Understood or not?
Yes.
Okay, so basically for this first and the second and the third also, है ना, I will give you answer for these three questions during the design. Okay, so you will understood in a better way during the design. Understood?